Right now, as you're watching this video, the Earth is spinning. Not slowly, not gently, but at a speed of over 1,600 kilometers per hour at the equator. That's faster than a commercial jet. We don't feel it because everything around us, the oceans, the atmosphere, the buildings, even our own bodies, is moving right along with the planet. It's our ultimate shared journey through space. But imagine this. No warning. No gradual slowdown. The Earth just stops instantly. What would happen? Would we be thrown into space? Would the ocean survive? Could life, as we know it, possibly continue? To understand the sheer chaos of that moment, we first need to appreciate what Earth's rotation actually does for us. We know it gives us our 24-hour cycle of day and night. But it's so much more than that. The spin of our planet is a hidden architect, shaping our weather, controlling ocean currents, and even slightly changing how gravity affects us. At the equator, the surface of the Earth is moving the fastest, over 1,600 kilometers per hour. As you move toward the poles, that speed gradually decreases, until at the very north and south poles, the rotational speed is essentially zero. This constant motion creates a subtle outward push called centrifugal force, which slightly counteracts gravity. It's why the Earth isn't a perfect sphere. It bulges at the equator and flattens at the poles. It's a tiny effect, but as we'll see, it's incredibly important. Now, let's go back to our thought experiment. Imagine all of that motion vanishes in a split second. The solid ground beneath our feet halts. But everything on it, the air, the water, every loose object does not. The laws of physics, specifically inertia, state that objects in motion stay in motion. So when the planet stops, everything that isn't nailed down keeps going, eastward, at over 1,600 kilometers per hour. At the equator, the atmosphere, and the oceans would suddenly be launched at a speed faster than sound. In the very first second, the effects would be apocalyptic. Buildings would be torn from their foundations, as their bases stopped, but their upper floors continued moving. Anyone standing on the surface would be flung eastward at hundreds of meters per second, tumbling across the landscape like a pebble in a landslide. No human could survive this initial moment. Airplanes in the sky would instantly lose control. Not because their engines failed, but because the atmosphere itself would become a global shockwave. Winds moving faster than the strongest hurricanes ever recorded would scour the face of the continents. These aren't ones that last for minutes. They would rage for days, as the atmosphere, once set in motion, would take an incredibly long time to slow down due to its own momentum. Now let's talk about the oceans. Water has immense mass, and mass means momentum. When the Earth stops, the oceans don't. They continue their eastward surge, piling up against continents in a single colossal wave. We're not talking about normal tsunamis. We're talking about mega-tsunamis thousands of meters high, wiping entire coastlines from the map in an instant. But something even more dramatic happens next. Remember that centrifugal force? The one that makes the Earth bulge at the equator? That force is also responsible for keeping ocean water distributed around the planet's midsection. When the rotation stops, that force disappears. Gravity takes over completely. Water, no longer held at the equator, begins to migrate toward the poles. Over days and weeks, the oceans would literally drain away from the equator, flowing north and south. This would expose vast stretches of the ocean floor, creating a new, dry landmass ringing the planet's waist. The Mediterranean Sea would disappear. The Caribbean islands would become mountains in a vast, arid basin. Meanwhile, at the poles, the influx of water would be catastrophic. The Arctic and Antarctic regions would be submerged under a new, deeper global ocean, flooding lands that were once frozen solid. Earth's geography would be permanently and unrecognizably rewritten. The chaos doesn't stop with the land and sea. Earth's rotation also choreographs the movement of our atmosphere. The Coriolis effect, a direct result of the planet's spin, is what gives our weather its complexity. It shapes global wind patterns, directs the jet streams, and gives storms like hurricanes their signature rotation. Without rotation, the Coriolis effect vanishes. Weather, as we know it, completely collapses. Instead of complex, swirling wind patterns, the atmosphere would reorganize into a much simpler and far more brutal system. Hot air would rise at the superheated equator, flow directly toward the frigid poles in massive, straight-line winds, then cool, sink, and return to the equator. This would create relentless, unbroken wind systems moving in straight lines across the continents. Hurricanes couldn't form, but the replacement would be far worse. Constant, planet-spanning windstorms that never, ever stop. And what about day and night? If the Earth stops rotating but continues to orbit the Sun, one side of the planet will face the Sun for 6 months straight, while the other side is plunged into 6 months of darkness. Let's imagine it gets worse and the Earth becomes tidally locked to the Sun, with one side permanently facing it. On this day side, temperatures would rise relentlessly. Without rotation to distribute the heat, the surface would become a scorched desert, hot enough to boil water. Any remaining surface water would evaporate, contributing to an oppressively thick, hot atmosphere. On the night side, the opposite would happen. Temperatures would plummet to hundreds of degrees below zero. Oceans would freeze solid, all the way to the bottom. The atmosphere itself would get so cold that gases would condense and fall as snow, leaving a near vacuum behind. Between these two extremes of fire and ice, there might be a sliver of hope, a narrow band known as the Twilight Zone or the Terminator Line. In this perpetual dawn or dusk, temperatures might remain stable enough for liquid water to exist. If any form of life were to survive, it would be here, in this thin, habitable ring around the planet. But survival would be a constant battle. Plants depend on day-night cycles. Animals rely on stable climates. And human civilization is built on infrastructure, agriculture, and predictable weather. All of that would be gone. Within weeks, most complex life on Earth would be extinct. Not just from the violent stop itself, but from the long, unforgiving consequences that follow. Our planet feels so calm, so solid, so permanent beneath our feet. But this thought experiment reveals something unsettling. Life on Earth exists not just because of our distance from the Sun or the presence of water, but because of motion. A delicate, invisible spin that we never feel, yet absolutely depend on for our very survival. And this is only the beginning of the chaos. In our next video, we'll explore what happens in the months, years, and even centuries after the Earth stops rotating. Could the planet ever recover? Could life find a way to adapt to this new, brutal world? As the days turn into weeks, Earth begins to settle into its new, terrifying reality. The initial violence has passed. The shockwaves, the global winds, the collapsing cities, most of that raw destruction has already happened. But now comes something far more dangerous, stability, because a motionless Earth does not mean a calm Earth, it means an unbalanced one. With no rotation, the oceans have already begun their slow, epic migration toward the poles. Imagine vast amounts of water once spread across the globe, now sitting frozen or pooled in the far north and south, forming two new, deep polar oceans. The equatorial regions, once rich with rainforests and warm seas, are now a different world. They are dry, exposed, and cracked. Salt flats stretch for thousands of kilometers, glistening under a relentless sun. Entire marine ecosystems are gone, wiped out not by heat or cold, but by the simple disappearance of water. And without oceans in the tropics, something critical breaks: the carbon cycle. On our modern Earth, oceans are incredible sponges. They absorb enormous amounts of carbon dioxide and act as a global thermostat, redistributing heat. With those equatorial oceans gone, carbon dioxide begins to accumulate in the atmosphere unevenly. On the sun-facing side of the planet, the intense, unending heat causes rocks to release trapped gases. Volcanic activity starts to increase, not because the magma has changed, but because the pressure systems on the surface have been completely rewritten. Meanwhile, on the dark side of Earth, the exact opposite happens. The atmosphere itself begins to freeze. Nitrogen and oxygen, the very air we breathe, start to condense in the extreme absolute cold. Snowfall no longer consists of water but frozen air. Over time, the atmosphere becomes thinner and thinner. Breathing becomes impossible outside of very specific, limited regions. Now, imagine standing at the boundary between light and darkness, the twilight zone. This narrow ring circles the entire planet like a scar. Here, temperatures are neither boiling hot nor freezing cold. Water can still exist as a liquid. The winds are still incredibly strong but survivable. This is the only place where any kind of long-term survival might even be possible. But even here, life is a desperate struggle. Without a rotating planet, the magnetic field begins to weaken. Earth's magnetic field is generated by the movement of molten iron in the core, a process driven by our planet's spin. When rotation stops, this dynamo effect slowly decays. As the magnetic field fades, Earth loses its shield against the cosmos. Harmful solar radiation and cosmic rays begin to strike the surface directly. For any living thing, this is a catastrophe. DNA damage increases. Cancer rates would skyrocket. And it's not just biological systems that suffer. Electronics fail. Any remaining technology, from simple radios to complex computers, becomes unreliable and eventually useless. Our invisible shield is gone. And then there's the sun. On the permanently lit side, the sun never, ever sets. Think about what that does to plants. They can't rest. Photosynthesis runs uncontrollably, 24/7, until the plants essentially overheat, dehydrate, and die. Forests would burn, not from fire, but from pure, unrelenting thermal stress. On the dark side, of course, plants never receive any light at all. Within a single year, most vegetation on Earth is gone, and the animals soon follow. The herbivores starve first, with nothing left to eat. The carnivores follow shortly after. Entire food chains, built over millions of years, collapse from the bottom up. What about us? Humans, if any survived the initial catastrophe, would face impossible challenges. Agriculture, as we know it, is no longer viable. The regular rhythm of seasons is gone. Soil either dries out, freezes solid, or is scoured away by perpetual winds. Even our most advanced technology offers little help. Energy systems fail. Supply chains vanish completely. Our great cities, monuments to our civilization, become silent tombs. It's possible that small, isolated groups might survive for a while. They could cling to life in the twilight zone, maybe using artificial lighting for underground farms, and tapping into geothermal energy for warmth and power. But this isn't a future, it's just a delay. Now let's zoom out and look at Earth on a timescale of decades. The ice continues to accumulate on the dark side, creating a massive, permanent ice cap. This increases the planet's albedo, meaning it reflects more sunlight back into space, which cools the planet even further. So the bright side gets hotter and the dark side gets colder. This extreme temperature difference intensifies the wind speeds again, creating permanent, violent atmospheric circulation between the two hemispheres. This constant energy imbalance makes any kind of long-term climate stability impossible. Earth would begin to resemble a hostile exoplanet, one that astronomers might look at through a telescope and classify as barely habitable, if at all. But could Earth ever recover? What if somehow the rotation restarted after years or even centuries? The damage wouldn't simply reverse itself. The oceans would take thousands of years to redistribute across the globe. The massive polar ice caps wouldn't melt evenly. The atmospheric composition would remain dangerously altered, and the mass extinctions would already be complete. The book of life on Earth would have had its final chapter violently torn out. Our planet has survived incredible trauma in its past. It's weathered asteroid impacts, supervolcanoes, and devastating ice ages. But a sudden stop in its rotation would be something else entirely. It wouldn't be a single, definable disaster. It would be a new, permanent condition. A slow, inescapable unraveling of everything that makes our world work. What makes this scenario so deeply unsettling is not how dramatic it is, but how it reveals our dependence on something we never, ever notice. We fear earthquakes, storms, and eruptions. But the most important motion on Earth is silent, invisible, and constant. And if it ever stopped, the planet wouldn't explode. It would simply become unlivable. In the final part of our series, we're going to look even deeper beyond the mechanics of survival. We'll ask a final, crucial question. What does this thought experiment tell us about Earth, about life, and about the incredibly fragile balance that keeps us all alive in the vastness of the universe? What if the Earth stopped spinning? Not in a sudden, catastrophic jolt that sends everything flying, but a slow, gradual halt until it stands perfectly still. What would our world look like then? By now, Earth is no longer the planet we recognize. What remains is not a world in chaos, but a world in a deadly equilibrium. The oceans, once vast and dynamic, are locked at the poles. The atmosphere is thin, uneven, and dangerously unstable. Most of the surface is either scorched by an unblinking sun or frozen in perpetual night. The delicate, intricate systems that once nurtured life have fallen completely silent. Yet Earth itself is still here. The mountains have not vanished. The continents have not shattered into pieces. Gravity still holds everything firmly in place. The planet did not die. Life did, and that distinction, that single difference, matters more than you can imagine, because it reveals something truly profound about how incredibly rare and fragile worlds really are. Think about it. Astronomers have discovered thousands of exoplanets orbiting distant stars. Many of them are roughly the size of Earth. Some even lie within what we call the habitable zone, that sweet spot where liquid water could potentially exist on a planet's surface. But as we're learning, size and distance are not enough. Not even close. Rotation matters. Most of these potentially Earth-like worlds are what we call tidally locked. This means one side is forever facing its star, trapped in an endless, searing day, while the other side is eternally frozen in darkness. Their climates, if they have any, resemble the frozen and burning halves of our now motionless Earth. This simple fact reveals a breathtaking truth. Earth isn't just special because of where it is in the solar system, but because of how it moves. Its constant, steady rotation is the engine that drives everything. It distributes the sun's heat around the globe, preventing extreme temperatures. It stabilizes our climate, creates weather patterns, and sustains our liquid oceans. It even powers the magnetic field that acts as a shield, protecting all life from deadly solar radiation. Without that gentle, continuous spin, Earth becomes just another silent, barren rock floating in the vast emptiness of space. Now, let's consider time. On a motionless Earth, over millions of years, the planet would continue to evolve geologically, but in a strange, lifeless way. Volcanoes would still erupt, spewing molten rock onto the barren surface. Tectonic plates would still grind against each other, albeit perhaps more slowly. New land would form, even as old land erodes under a thin, weak atmosphere. But without life, these monumental processes would have no witnesses. There would be no forests to grow back after a volcanic eruption. No oceans teeming with countless organisms, from microscopic plankton to giant whales. And certainly no civilizations to rebuild cities from the dust. The fossil record, our planet's great diary, would end abruptly. It would mark the precise moment when Earth stopped turning, a final, silent chapter in the story of life. Imagine, if you will, that an alien civilization were to stumble upon this planet in the distant future. What would they find? They might detect the telltale signs of water ice at the poles. They would see vast continents of rock and dust. They might even analyze the remnants of our atmosphere. But they would find no signal. No radio waves carrying our music and conversations out into the cosmos. No city lights painting the dark side of the planet with a web of artificial stars. They would find absolutely no evidence that a thinking, dreaming, building species ever existed here at all. They might classify Earth as a failed world, a planet that had potential but ultimately fell silent. And the tragedy is, they wouldn't know how close it came to succeeding. They wouldn't know about the symphonies, the art, the scientific discoveries, or the simple act of a child laughing. All erased. And yet, just one simple change could have prevented all of this devastation. Motion. The Earth's rotation is not a dramatic, showy force. It doesn't shake the ground beneath our feet or light up the sky with fireworks. It happens quietly, endlessly, at a speed we never even feel as we go about our daily lives. But it is the fundamental reason the sun appears to rise in the morning and set in the evening. It's the reason storms form over the oceans and not over the deserts. It's the reason our oceans stay where they are instead of migrating to the poles. And most importantly, it's the reason life had the time billions of years of stable, predictable conditions to evolve from simple cells into the breathtaking complexity, intelligence, and curiosity that defines us. This thought experiment isn't meant to frighten you. It's not a prediction of doom. It's meant to be a reminder, a moment of perspective. We live on a planet that works. It works not by some random chance, but through a delicate, perfect balance. A balance of gravity and motion, of heat and distance, of chemistry and time. Change just one of those core elements and everything else follows, cascading into a state that no longer supports us. So the next time you watch the sun rise, casting long shadows and painting the sky with color, remember this. That slow, graceful arc across the sky exists only because the ground beneath you is turning. That gentle, reliable cycle of day and night is not a guarantee. It is a privilege of motion. It is a gift of physics. And as long as the earth keeps spinning, life has a chance to continue, silently, relentlessly, perfectly balanced on the very edge of existence. Thank you for watching.